I'm Anil Kumar. Welcome to my series on quadratic functions. We'll discuss about vertex of a parabola in this particular video. So first, we'll state some significances of vertex of the parabola. Then we will discuss strategies to find vertex of a parabola. And with the help of these examples, we'll find vertex using different strategies, right? So now let's first understand what is the vertex of a parabola. Now, in general, the equation of a parabola is given as y equals to ax square plus bx plus c. Right? Now, if the value of a is greater than 0, that means it is positive, then the parabola will open upwards, right? And if a is less than 0, that means it is negative, then the parabola will open downwards. Vertex is always at the turning point, right? So this is the vertex. So if a parabola always has axis of symmetry. So that is the axis of symmetry, right? And the vertex lies on the axis. If it is opening upwards, as shown in the first case, in that case, we'll have absolute minimum value, right? So we'll have absolute minimum value at vertex. Is that clear to you, right? If it is opening downwards, that is a is negative, leading coefficient, a is called the leading coefficient. In that case, this point here will be absolute maximum value, right? Clear? So that is some importance of the vertex. It goes through the axis of symmetry. It is a turning point. So in any case, it is always. So vertex is a turning point. So these are important things to summarize about the vertex, right? So it represents absolute maximum or minimum. It is a turning point and it lies on the axis of symmetry, right? Now let's look into different strategies which we can apply to find the vertex. The very first one here is x squared plus 10x, that equation. Now we could actually graph this and find the vertex. So that is one strategy. Second one is x squared minus 4x minus 5. 5 is 5 times 1 as product and sum. If I take minus 5 and plus 1, we get minus 4. So we could factor easily, so we will use factoring. Here we cannot factor. Now, good strategy is partial factoring. This could be new for some of the students. However, it is a very effective method. So let me write down. Now the last one, it involves that decimal thing. So it's very difficult to factor also. So such things we can always do ultimately by completing the squares. Now this is a universal method. Everybody applies completing the squares to find the vertex. Is that clear to you, right? Most of the time. So you will soon learn that the other techniques are not bad, and especially partial factoring could be even better than completing the squares many times. So now let's look into our examples and see how effective these techniques are to find the vertex of a parabola. Okay? The very first one here is y equals to x squared plus 10. So we have decided to utilize graphing techniques to find the solution, right? So if I substitute 0, 0 is always a good value to substitute, and the function is y equals to x squared plus 10x. Then at 0, we get the value 0, right? Now if I substitute a value which is positive 1, then we get 1 plus 10, which is 11. And if I substitute 2, then we get 4 plus 20, which is 24, correct? So pretty high value. So let's try the negative values. So if I substitute now, let us say we substitute the value, which is, we already got 1, 0, right? The other one is expected at minus 10, right? So let me substitute some values, like in this case, minus, let's say 5, okay. So if I substitute minus 5 here, we get 25, which is 5 square positive, and minus 50, so we get minus 25, right? And if I substitute a value which is minus 10, I do get a value which is 0, right? So we get some 0 here. We can substitute other values also. Let me write this like this. Minus 10 will give us 0. And if I substitute minus, I don't want to do a very high value here, since let us say minus 12. Okay. So if I substitute minus 12 here, we get 144 minus 120. So we get here 144 minus 120, which is 24, right? So we get a symmetrical point at minus 12. Okay. So if you use graph paper to plot this, what you get really is something like this. So it is a parabola which opens upwards, and it seems that it has two zeros. One is at 10, the other one is at 0. So the average of these two is your vertex. Do you see that? So which is at minus 5. So if I draw the axis like this, then the parabola will have two zeros. One is at 0, the other one is at minus 10. And it is opening upwards. So basically, I could sketch a parabola which is kind of like this. Okay, so something like this, right? This has to be a straight line. Okay. So we have two zeros, one at 0, one at minus 10, and this value, which is the axis, has a value at minus 5, the value is minus 25. Is that clear to you, right? So at minus 5, we get this as minus 25. Now you can plot the other values also. At 2, we have 24, and at minus 12, let's say this value is, now here we have this value at 2, and there we have this as minus 12. Is it okay? And this value here is 24. So that's a y value, and this is the x value. So on a graph paper, when you sketch, you kind of like this. And from the parabola, you get your x-intercepts, vertex, a lot of information, right? Now, to find the vertex, clearly the turning point, so we get our solution that the vertex is at minus 5 minus 25. Correct? Now let's take up the next question. Now the second example is y equals to x squared minus 4x minus 5. We can easily factor this. So we'll factor and find the vertex. So we have y equals to x squared minus 4x minus 5. To factor, we are looking for two numbers. I normally use p and q, whose product should be minus 5, right? So a times c, a is 1, and whose sum should be coefficient of x, which is minus 4. So the two numbers could be 5 and 1. Since we want sum to be negative, bigger number should be negative. So we could easily factor this and write this as x minus 5 times x plus 1, right? I'm not really discussing steps to factor, but we are using these strategies, correct? So once you factor, you get two x-intercepts, right? So after factoring, we know we have got this. So this actually gives us x-intercept. So we have x-intercept at, if I say x minus 5 equals to 0, this is at x equals to 5. And if I say x plus 1 equals to 0, we get x equals to minus 1. So now let's try to understand the concept to get the point of vertex. So we have two x-intercepts. One is at 5, the other one is at minus 1. Parabola is opening upwards. So let's say this is the parabola which opens up, right? And the vertex for us are at, the x-intercepts are at minus 1. So let's say this is the x-axis. 1 is at minus 1. Let's say this point is at minus 1. This point is at 5, right? So the y-axis will be somewhere here, let's say. Okay. Now clearly, as you can see from here, the vertex lies midway between the two x-intercepts. So we call this as the axis, right? So we can find out what is the axis of symmetry, which is midway, right? So we add these two and divide by 2. So it is at x equals 2. Add them. We got 5 minus 1 over 2, which is 4 over 2, or it is at 2. So this axis is at x equals to 2, right? So the vertex lies on the axis itself. So to find the y value, we'll substitute 2 in our equation. Is that clear to you, right? So that is the concept. So y value will be, we'll substitute 2. Let's put it in this factored form. Easy for calculations also, right? 2 plus 1, right? So which gives us a value which is minus 3 times 3, which is minus 9. So that coordinate is minus 9, and this is at 2. And therefore, we can say vertex will be at x value of 2 and y value of minus 9. So as you can see, this parabola will have a minimum, absolute minimum, at x equals to 2, and the minimum value is minus 9. Is that clear to you? Right? So let's move on and take the next example, which is we need to find the vertex of a parabola y equals to x squared plus 12x plus 1. Now we are going to use the strategy of partial factoring here. Now it cannot be factored since 1 and 6, the product of 6 will not give you sum of 10. So let's understand partial factoring technique. 6x squared plus 12x plus 1. So in this, we look only into the first two terms, which are 6x squared and 12x. Take whatever is common between them. It is 6x which is common. So we could write this as x plus 2 plus 1. Now that really means what? It really means that at x equals to 0, we have y equals to, if I put this 0, everything is 0 here, we get y equals to 1. And at x equals to minus 2, when this factor is 0, even then we get y equals to 1, right? So we get y equals to 1. So that basically means in this particular case, when we have a parabola which is opening upwards, then we notice that the y value is 1. Let's say this is y equals to 1. Y value is 1 at two x values, and both these x values are 0 and minus 2, right? So basically, since this is at 0, so what we will do here is that is also a y-intercept, so we can actually, x equals to 0 and minus 2. So this one is 0, right? So we'll draw y-axis here. So this is 0. We want y equals to 1. So let's do like this. So that becomes our coordinate axis, right? So at 0, we have y equals to 1. And at x equals to minus 2, we have y equals to 1. Perfect. So the line of symmetry should be midway, right? So let me draw midway a line of symmetry. So the axis of symmetry will be where? Axis of symmetry in this case will be the average value of minus 2 plus 0 divided by 2, which is minus 1, right? So this is at x equals to minus 1. Clear? So to find the y value, which is this value, the minimum value here, we'll substitute minus 1 in our equation, right? So y equals to, let us substitute minus 1 in the original equation, plus 12 times minus 1 plus 1. That gives you 6, and this gives you minus 12 plus 1, right? So minus 6 plus 1 is minus 5, right? So we get a value which is minus 5. So the vertex happens to be at, we can now write down our solution of the value of the vertex. So we get the vertex at x value of minus 1 and y value of minus 5. Is that clear to you, right? So you could use this equation also. If I substitute minus 1, we get minus 6 here. And here we get 1. Minus 6 plus 1 is minus 5. Clear? So that becomes the vertex, which is minus 1, minus 5. So I hope this partial factoring method is absolutely clear. So we just take the first two terms, factor them, and then find the solution. Correct? The last method is the most commonly used. We'll use completing the squares now. You can look into my videos for more examples. So here we have y equals to minus 0.5 x square plus 3x plus 4, right? So let me write 0.5 as half. So I'm rewriting this equation, writing 0.5 as half, right? Now, whatever is the coefficient of x square is taken common between the first two terms. So you do kind of partial factoring, right? So we get minus half, but you don't factor out x. That is the difference, right? So we get here x squared. The sign will change. Dividing by minus half gives you 6x here, right? Keep this constant term aside. So now we have x squared minus 6x. To complete the square, we add and subtract half of the coefficient of x. In this case, it is 3. So we'll add and subtract 3 square. Now adding and subtracting the same number means adding 0, which really doesn't change your equation, right? So we get here half, but that makes the 3 terms as perfect square. So we could write this as x minus sign and 3 from there whole square. Minus 3 square is minus 9 plus 4. Now, we can open this bracket, so you get minus half x minus 3 whole square, and when you multiply this, you get plus 9 over 2, and then you get plus 4, right? So that is what you get. Now you can combine these two terms. You get minus half x minus 3 whole square. So plus 4 times 2 is 8. 8 plus 9 is 17 over 2, right? So that becomes your vertex form. Now, this vertex form really means what? Minus means the parabola is going to open downwards, right? And this point here, which we are calling the turning point of the vertex, will be at 3. And when this portion is 0, we get 17 over 2, right? 17 over 2 as the y value, right? You can write 8.5 if you want to, right? So that becomes our vertex. So in general, if we have a formula y equals to a x minus h whole square plus k, then the vertex is at hk, right? So that is general formula. Okay, so I hope with these examples you got fairly good idea about how we can calculate vertex and how different methods can be utilized to find the vertex, and what is also the significance of this particular point. This also helps us to solve many word problems, mainly related to optimization, when we are trying to maximize volume, area, or we are trying to minimize the cost. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.